Okay, think about this. What if an AI could read a complex document, but not like a robot, like a person? I mean, really read it, following the flow of a table, jumping from a column to a footnote, and actually getting the structure of a math formula, all with a kind of human intuition. Well, we're going to dive into that because a new model called DeepSeek-OCR 2 is trying to pull off exactly that.
It sounds like a simple question, right? But for years, the way AI has answered it has been, well, surprisingly robotic. You see, most models see things in a way that's just fundamentally different from how our brains work. So today, we're going to break down a new paper that totally challenges that old method, and it gets its inspiration straight from how we see the world.
So here's the core difference in a nutshell. The standard AI approach, it's like a robotic lawnmower, just going from top left to bottom right no matter what. It'll just plow through a two-column layout or a complex table without any real grasp of the structure. But that's not how we work, is it? Our eyes are smart, they're flexible. We follow the flow of meaning, not just some rigid coordinates on a page. And that gap, that's exactly what DeepSeek-OCR 2 is trying to close.
All right, so here's the game plan for today. First, we'll talk about why the old way is so broken. Then we'll see how human vision inspired a fix. We'll introduce the new model, peek under the hood at how it works, check out the results, and finally wrap up with what this all means for the future of AI. Let's get started.
All right, first up, let's talk about the problem. Conventional AI models, they have what the paper calls an unwarranted inductive bias. Okay, that's a super technical term, right? But it's just a fancy way of saying they're kind of forced to see the world in a way that just doesn't make any sense for complex stuff like documents or charts.
To really get what's going on, imagine this. You take a beautifully designed magazine page and you run it through a paper shredder. Then you tape all those little strips together, end to end, into one long chaotic line. That's pretty much what traditional AI does. It flattens a complex 2D image into a simple 1D sequence. And in doing that, it just completely destroys all that rich, logical structure. You know, the columns, the tables, the little call-out boxes, all of it, gone.
So if the machine's way is so fundamentally broken, where do you even start to look for a better model? Well, the researchers basically looked in the mirror. The big aha moment for this whole new approach came directly from understanding how we see things, our own cognitive wiring.
I mean, just think about tracing a spiral with your eyes for a second. You don't scan it like a grid, right? No way. Each place you look causally depends on the last one as you follow that curve. It's this natural, logic-driven flow. And that is exactly what the researchers wanted to teach an AI to do.
And they actually gave this idea a pretty cool name, visual causal flow. It's the central idea here, the core principle. It's all about an AI learning to read in a way that actually makes sense, where the order it processes information is dictated by the content itself, not by some dumb, predefined grid.
And that brings us to the hero of our story, DeepSeek-OCR 2. This is the model that was built from the ground up to really embody this whole principle of visual causal flow. So the key innovation here, the secret sauce, is a new component called DeepEncoder V2. What they did was replace the standard, rigid vision component, things like clip that just match images and text, with this new, super smart LLM-style architecture. And this new encoder, it doesn't just see pixels. Its whole job is to learn the most logical reading order for any image it sees, and then feed that intelligent sequence to the main language model. Okay, so that's the what. But how does it actually do that? Let's pop the hood and take a quick look at the mechanics of how this new encoder works its magic. So, looking at the big picture, here's how it flows. The image comes in, and it hits that key component we just talked about, DeepEncoder V2. This is the magic box where all the crucial reordering happens, way before the information even gets to the main model for interpretation. And really, the fundamental change boils down to this. They swapped out an old, rigid component like clip for this new, flexible, LLM-style architecture. And believe it or not, that one single change is what gives this model its new superpower. Okay, the process itself breaks down into about 4 steps. First, just like always, the image gets broken down into little patches or visual tokens. But then, step 2, they add in these special causal flow queries. Now, you can think of these as tiny little agents or scouts that get to see all the visual tokens at once. Then, and this is the cool part, they use a custom attention mechanism to pick out those tokens one by one, but in a logical, human-like order. Finally, only this newly reordered, coherent sequence gets sent on to the main LLM.
The real magic here, the trick, is a custom attention mask that has two jobs. The first part is bidirectional, which means it lets all the visual tokens see each other at the same time. This gives the AI a complete global understanding of the image, kind of like our peripheral vision lets us see the whole scene. But then, the second part is causal, and it forces those little causal flow queries to arrange the tokens into a logical step-by-step sequence, so you get the best of both worlds, the big picture context and the smart sequential logic.
Okay, this all sounds amazing in theory, but the million-dollar question is, did it actually work? Let's check out the results.
And the short answer is, yeah, a big yes. On a really tough document benchmark, DeepSeek-OCR 2 showed a 3.73% overall performance gain over the last version. Now, I know that might not sound like a huge number, but trust me, in the world of AI benchmarks, that is a very significant leap forward. But this table? This tells an even cooler story. Check out DeepSeek-OCR 2. Not only does it get a higher overall score, but look, it does it using fewer visual tokens. That means it's more efficient. But the really important number, the one to watch, is in that last column, reading order edit. Here, lower is better, and you can see this massive drop from 0.085 down to 0.057. That right there is the hard data, the statistical proof that this new causal flow thing is creating a way more logical reading path. So, okay, this model is clearly a lot better at reading documents. We've established that. But the implications of this research go way, way beyond just OCR. Let's zoom out for a second and look at the real big picture here. This quote from the paper really gets to the heart of it. The researchers think that breaking down the super complex problem of 2D understanding into two much simpler one-dimensional tasks might just be a huge breakthrough. And what are those two tasks? Simple. First, figure out the right order to look at things, and second, understand the content in that order. This could be a whole new path toward an AI that can genuinely reason about any 2D space, not just recognize patterns. So, why does all this matter? Well, for one, it's a huge step towards AI that can truly reason about the visual world, not just, slap a label on it. It also points to a future of these unified omnimodal AIs, where maybe one single powerful encoder could process images, audio, and text just by learning the unique causal flow of each one. Ultimately, this is all about building AI that's just more efficient, more logical, and frankly, a little more aligned with how our own brains work. And all of this leaves us with one final big thought. The researchers here have successfully taught an AI to read a page by following the same logical paths that our own eyes take. So it just begs the question, if AI can now learn to read like a human, what's it going to learn to see like a human next?